right, this is lesson 6.3. We're doing operations with roots. When you're adding and subtracting roots, you have to have the numbers under the square root. They have to match. They have to be the exact same number. So on our first problem, we had -2 root 6 minus 3 root 6. Well, -2 minus 3 is -5. And since the numbers match, we just kept the root 6. So -5 root 6 is what you get when you take 3 root 6 away from -2 root 6. Similarly, on number 2, the root 3's matched. So I know I'm going to have a root 3 in my answer, but -3 plus 3 means there were 0. 0 root 3's. 0 times anything is just 0. Okay, so when those match, you just add or subtract whatever number you have in the front and keep the root. If they don't match, like this is an 8 and this is a 2, you have to first simplify and see if you can make them end up being the same thing under the square root. The root 2 doesn't simplify. There's no perfect square in there, but 8 does. So square root of 8 is the same as square root of 4 times square root of 2, and the square root of 4 is 2. So I'm going to replace the square root of 8 where I see that with 2 root 2. Okay, then we will do 3 times root 2, which is 6 root 2, minus the 2 root 2, and that gives us 4. We do the same over here. 12 and 27 can both be simplified. They can be broken down into perfect square times a number. The perfect square that goes into 12 is 4. 4 times 3 makes 12. The square root of 4 is 2. 27, the perfect square that goes into 27 is 9. Square root of 9 is 3. 9 times 3 makes 27. And I replaced square root of 12 and square root of 27 with what we simplified them to be. Multiplied, and added these together. -6 and -9 make -15. Okay. All right, so that was a recap of the adding and subtracting and also the simplifying. Now we're going to go on to multiplying. When we multiply with square roots, we are simply distributing. But we have to remember numbers on the outside get multiplied together, numbers on the inside get multiplied together. So this is a good review in distributing as well. So go ahead and write 5 and 6 down on your page. We'll work through those in a second. I want you to have them written down first. All right, so we are going to start with the 5 root 3. It's going to be multiplied times both of these. Then we'll go to the 4 and multiply them, and then see if we have any like terms to combine. So 5 root 3 times root 3 is going to be 5 root 9. I just multiplied numbers on the outside and numbers on the inside together. And 5 root 3 times -4 is -20 root 3. Does everybody agree? Y'all see where those numbers came from? So if inside the square root gets multiplied together, numbers on the outside, they stay on the outside. We'll move over to this 4. 4 times root 3 plus 4 root 3. And 4 times -4 is -16. And now we'll simplify if we can. If there are any square roots that are perfect squares, we're going to do that. Any of these square roots we can actually take the square root of? What's the square root of 9? 3. So I'm going to replace the square root of 9 with a 3. So 5 times 3 is just 15. So I'm going to replace this with a 15. So if you need to make sure you remember, this is 3. Okay. So 5 times 3 is 15. Negative 20 root 3 and 4 root 3 make negative 16 root 3. Then I have a minus 16 at the end. Are there any like terms that we can combine that are left? The 15 and the negative 16, and that's going to make a negative 1. So we distribute. If there's anything that's a perfect square, we want to actually evaluate it. 3 times 5 is 15. We combine these two together. They both had root 3, so they can be combined together. And notice that 15 and negative 16 are also like terms. They'll add together to be negative 1. All right, thumbs up if that problem's okay with you guys. All right. Quinte, you all right? You sleeping? Thumbs up. Okay. All right, let's try number 6. Similar to the last one. Negative 2 root 3 times root 3 is negative 2 root 9. When you multiply, you do actually multiply the numbers, unlike when you're adding and subtracting. Negative 2 root 3 times root 5 is negative 2 root 15. Root 5 times root 3 is root 15. And root 5 times root 5 is root 25. Are any of these perfect squares? The 9 and the 25. So this root 9 is just going to be 3. Negative 2 times 3 is negative 6. Negative 2 root 15 plus 1 root 15 is negative 1 root 15. And what's the square root of 25? 5. And then negative 6 plus 5 is negative 1 minus 1 root 15. So multiply them out. Do you have roots that are the same that you can add together? Do you have roots that are perfect squares? That's what you'll check after you multiply. But when you're multiplying, you do actually multiply the numbers that are inside. They don't have to match. Okay. That is your multiplying, especially when you're doing binomials. Any questions on multiplying? We are going to move down to rationalizing the denominator. This is when you have a square root in your denominator. We have 2 different types. The first kind we're going to do, they just have a single, oh gosh, it keeps moving, a single square root in the bottom. The next kind is going to have 2 of them. So to rationalize the denominator, if you just have a square root in the bottom, you're going to multiply on top and bottom by that same square root. So to do that, so we can multiply, if we do the same thing on the top and the bottom, it's like multiplying by 1, so it's not going to change our value, but it's going to make it where we don't have a square root in the denominator anymore. Numbers under the square root, we call those irrational numbers, just a reminder. So when they say rationalize the denominator, they want to get the square root out of the bottom. So they want to take an irrational denominator and make it rational. So this is really just a formatting thing. People don't like to leave square roots in a denominator, so we have a process to get those out of there. So we're going to multiply the top and bottom by whatever root we have on the bottom. And you guys probably remember this from geometry. I know you had to do this in that class. If I have a square root of 5 on the bottom, to get rid of it, I'm going to multiply by square root of 5 on top and bottom. Then I just multiply across, and I won't have a square root in the denominator anymore. 2 times root 5 is just 2 root 5. And the square root of 5 times the square root of 5 is the square root of 25. And is the square root of 25, is that a perfect square? Yep, and the square root of 25 is 5. You'll notice after you do these, when you multiply two roots together that are the same, you just end up with whatever was underneath the original square root. So our answer is 2 root 5 over 5. Do we have a square root in the denominator anymore? Nope, we're good to go. 2 and 5, they were different types of numbers. 2 was outside, 5 was inside. So we can't actually multiply the numerical part together. We just have to put the 2 in the front. It's a little different on number 8. So we have root 2 over root 5. What is our square root on the bottom? Square root of what? 5. So we'll do that on top and bottom. That makes the square root of 10. We actually multiply them together because they were both in the square root sign, over the square root of 25. And the square root of 25 is 5. And you always want to check on these problems when you get to the end to see if you can actually, if you could pull a perfect square out like we could with 8 or 12 or 27. But 10 doesn't have a perfect square in it. But you do want to check those just to make sure. Okay.
I'm a little bit lost on like this one. I don't know how you got from like 2, 5 to 5, 5.
Here?
Yes.
You pick the root on the bottom, which is the square root of 5, and we multiply the top and bottom by that. So we put that next to it. And what that's going to do is when we multiply them, we won't have a square root anymore in the denominator. So that's our only goal, is we just want to get rid of the square root in the denominator. So to do that, we have to multiply by the root on the bottom so that you'll end up getting just a regular number. It's just rewriting it. It's not like any operation. They just want us to not have a square root in the bottom anymore. So we just picked the one on the bottom. We have to do top and bottom so that it doesn't change the value. It's like multiplying by 1 if you have the same thing on top and bottom. And you just go across and see what you get. So these two are the exact same. If you put them in the calculator, root 2 over root 5 and root 10 over 5, it's the exact same numerical value, just rewritten a different way. Does that kind of help?
Yeah, that makes sense.
Okay. Sometimes when we're doing our rationalize the denominator, we have to simplify first. It makes it a whole lot easier. But these, we had a 2 and a 5. They couldn't simplify. Another 2 and a 5. But if you get to problems that you could simplify first, you're going to want to do that. Do 10 and 6 have something in common? What divides into 10 and 6? 2. So we always want to try to simplify them first. So this is the same thing as the square root of 10 over 6, which can be written as the square root of 5 over the square root of 3. So 10/6 is the same as 5/3. So you want to see if you can simplify it first. It's going to make it a lot easier in the long run to do the problem. So 10/6 is 5/3. Thumbs up if that's okay with you guys. Okay, so we simplify first. And then now we just do what we did before. What is the square root that's on the bottom? Root 3. So we do root 3 on top and bottom. That's the square root of 15. We've probably learned by now the square root of 3 times the square root of 3 is the square root of 9, which is just 3. On number 10, can you simplify that first? Is there a number that goes into 12 and 15? 3 goes into 12 and 15. So I can simplify this to 4/5, right? Right now, I'm going to look and see before I do my multiplying. The square root of 4, what is the square root of 4 the same as? The square root of 4 is the same as 2. So I'm going to rewrite that before I do anything else. So I simplified. And then to get to here, square root of 4 is the same as 2. So I rewrote that. You don't want any unnecessary square roots in your problem. Okay. And then now it looks exactly like the first one that we did on number 8. So what do we need to multiply on top and bottom? The square root of 5. So 2 root 5 over 5. Okay. That 5 looks a little weird. All right. And the very last thing is sometimes we don't just have one number on top and one number on bottom. We've got a combination. And for those, we're going to multiply on top and bottom by the conjugate of the bottom. And the conjugate is what we would have. Remember when we did those problems where we had to switch our signs with the i's and the square roots to get our second set of roots? That's what we're going to do on these. And the conjugate just means change the sign of the root. These are our last two problems. So to get rid of our square root in the denominator, I can't just do root 5 on top and bottom because that would just add a root 5 over here because I would be distributing it. So I'm going to have to multiply by what would be like the other root. If I had 5 minus root 5, if I was doing a solution or a 0, my other one would be 5 plus root 5. So when you multiply those together, they get rid of the square root part. So that's what we're going to choose to multiply. So if I have 5 minus root 5 on the bottom, I'm going to have to do 5 plus root 5. I'm changing the sign that's in front of the root. I have to do that same thing. These two have to match, otherwise I'll be changing the value of the problem. I'm going to write my answer underneath. I don't have enough space here, but I'm going to distribute like we did before. Negative 5 times 5, negative 25. Negative 5 times root 5 is negative 5 root 5. 5 times root 5. Root 5 times root 5. That's the top. So I'm distributing just like we did on the multiplying problems. I'll go ahead and write my arrows just to kind of help you out. See where we came from. Here, and here, and here, and here. Now we'll do the next one. 25. 5 root 5. Negative 5 root 5. And minus the square root of 25. Sometimes things will cancel out. I mean, there will always be stuff on the bottom that'll cancel out. Let's see what happens. I've got a 5 root 5 and a minus 5 root 5. Those are both going to go away on the bottom. It just so happens they also go away on the top because one's positive and one's negative. What's the square root of 25? This is just 5. This is 5. So negative 25 plus 5 is negative 20 on top. 25 minus 5 is 20. And this equals negative 1. Normally it's not so clean to end up to a whole number. There's a little bit of mess most of the time. But you introduce the conjugate, so change the sign of the root term on the bottom. Multiply that on top and bottom, and distribute the top, distribute the bottom, combine like terms. You want to see one more? Okay. I'm going to bring it down to the bottom here so I can have more space. So this is number 12, 2 plus root 5 over negative 5 plus root 5. So we are going to look at what we have on the bottom, negative 5 plus root 5. The conjugate is going to change this plus root 5 to what kind of root 5? A minus. So that's what we're going to pick to use. Negative 5 minus root 5 on top and bottom. Just like we had to introduce the roots in just the single ones, you've got to introduce these in these problems. So we just change the sign here. We don't change the sign in the front. That'll mess it up. And then we multiply. 2 times negative 5 is negative 10. 2 times negative root 5 is negative 2 root 5. It's my first 2. That was negative 10. This is negative 2 root 5. Next one is going to be minus 5 root 5. Then minus the square root of 25. Now do the bottom. 25 plus 5 root 5 minus 5 root 5 minus the square root of 25. I'm going to cancel what needs to cancel and then write out anything that's a perfect square. Does anything cancel on the top? On the bottom? Yep, these 5 root 5s will go away. One's positive and one's negative, so they're gone. This is just 5. This is 5. So now I can combine everything and write it together. Negative 10 minus 5 is negative 15. Negative 2 root 5 and negative 5 root 5 is how many root 5s? 2 and 5 make 7. And on the bottom, I've got 25 minus 5, which is 20. Okay, and occasionally you might have a number that goes into all 3 of these. This number here, here, and here, in which case it would be simplified, but we didn't in these.